Identify a Brønsted-Lowry conjugate acid-base pair in the reaction. Clearly label which is the acid and which is the base. CH₃CH₂COH and CH₃CH₂COO. Acid base. Or H3O+ and H2O. Acid base. 1 point is earned for writing or naming either of the Brønsted-Lowry conjugate acid-base pairs with a clear indication of which is the acid and which is the base. Determine the value of Ca for propanoic acid at 25 degrees Celsius. H3O+ equals 10 to the power, pH equals 10 to the power minus 2.79 is equal to 1.6 times 10 to the power minus 3 m. CH₃CH₂COO- equals H3O+ and CH₃CH₂COH equals 0.20 molar. H3O+ or CH₃CH₂COH is almost equal to 0.20 molar. State or assume that H3O+ much less than 0.20 molar. Ca equals CH₃CH₂COO- H3O+ /CH₃CH₂COH equals 1.6 by 10 to the power minus 3 to the power 2 divided by 0.20 is equal to 1.3 x 10 to the power minus 5. 1 point is earned for correctly solving for H3O+. 1 point is earned for the Ca expression for propanoic acid, or 1 point is earned for substituting values into the Ca expression. 1 point is earned for correctly solving for the value of Ca. For each of the following statements, determine whether the statement is true or false. In each case, explain the reasoning that supports your answer. 1. The pH of a solution prepared by mixing the 50.0 milliliters sample of 0.20 molar CH₃CH₂COH with a 50.0 milliliters sample of 0.20 molar NaOH is 7.00. 2. If the pH of a hydrochloric acid solution is the same as the pH of a propanoic acid solution, then the molar concentration of the hydrochloric acid solution must be less than the molar concentration of the propanoic acid solution. 1. False. The conjugate base of a weak acid undergoes hydrolysis at equivalence to form a solution with a pH greater than 7. CH₃CH₂COO plus H2O less than gives CH₃CH₂COH plus OH minus. 1 point is earned for noting that the statement is false and providing a supporting explanation. 2. True. HCl is a strong acid that ionizes completely. Fewer moles of HCl are needed to produce the same H3O+ as the propanoic acid solution, which only partially ionizes. 1 point is earned for noting that the statement is true and providing a supporting explanation. A student is given the task of determining the concentration of a propanoic acid solution of unknown concentration. A 0.173 molar NaOH solution is available to use as the titrant. The student uses a 25.00 milliliters volumetric pipette to deliver the propanoic acid solution to a clean, dry flask. After adding an appropriate indicator to the flask, the student titrates the solution with the 0.173 molar NaOH, reaching the end point after 20.52 milliliters of the base solution has been added. Calculate the molarity of the propanoic acid solution. Moles of NaOH equals 0.173 moles NaOH/1 liters NaOH. Asterisk 0.02052 liters NaOH is equal to 3.55 times 10 to the power minus 3 moles NaOH. Since the acid is monoprotic, 1 moles NaOH reacts with 1 moles of acid. Moles of propanoic acid is equal to 3.55 times 10 to the power minus 3 moles acid. Molarity is equal to 3.55 times 10 to the power minus 3 moles acid/0.02500 liters acid equals 0.142 molar. Or, since CH₃CH₂COH is monoprotic and, at the equivalence point, Moles H plus equals moles OH minus. Ma VA equals MBVB. Ma 25.00 milliliters equals 0.173 molar, 20.52 milliliters. Ma equals 0.142 molar. 1 point is earned for correctly calculating the number of moles of acid that reacted at the equivalence point. 1 point is earned for the correct molarity of acid. The student is asked to redesign the experiment to determine the concentration of a butanoic acid solution instead of a propanoic acid solution. For butanoic acid, the value of pKa is 4.83. The student claims that a different indicator will be required to determine the equivalence point of the titration accurately. Based on your response to Part B, do you agree with the student's claim? Justify your answer. Disagree with the student's claim. From Part B, above, Ca for propanoic acid is 1.3 times 10 to the power minus 5. So pKa equals log 1.3 by 10 to the power minus 5 equals 4.89. Because 4.83 is so close to 4.89, the pH at the equivalence point in the titration of butanoic acid should be close enough to the pH in the titration of propanoic acid to make the original indicator appropriate for the titration of butanoic acid. 1 point is earned for disagreeing with the student's claim and making a valid justification using pK, Ca, or pH arguments. 1 point is earned for numerically comparing either the two pK values, the two Ca values, or the two pH values at the equivalence point.